to be talking about simplifying square roots. And we're going to start off with the square root of 72. So you may be thinking, okay, if you know what we call your multiplication table, some people may call your time tables, you'll say, okay, well, 72, that is 8 times 9. Okay. 9 times 8, or whatever you want to call it. So another way you can write that, you can kind of separate, if you're multiplying, you kind of separate out the square roots. So I have square root of 8 times square root of 9. Square root of 9 is a perfect square. So we could say, oh, that's 3. Take out a 3, and then we still have square root of 8 left. And then we're trying to think, okay, in 8, well, 8 is 4 times 2. Okay, and I still have my 3 out here. So I have, instead of square root of 4, we can say, okay, well, that's 2. So I have 2 times 3 times, again, still have my square root of 2 left out here. So that's 6 on the square root of 2. Awesome. Okay. So that's as far as we can go because, 2 is prime, just 2 times 1. There's no more perfect squares there. So you may also say, well, 72, that's 12 times 6, okay? If you know your times tables all the way up to, 12s. Okay, kind of, similar, you kind of think, okay, 12, I can think of that's 4 times 3, and I still got my 6 here. So square root of 4, that's 2. I'm going to bring a 2 out. So I've still got 6 and the 3 here. 3 times 6 is 18, okay? So I'll say, well, 18, that's 9 times 2. And I've still got my 2 outside the square root. Square root of 9, okay, it's a perfect square. So that's 3. I'm going to bring out a 3. So I still got my 2. I'm going to say times 3. And then I still have root 2 left. Okay, well, same answer, which it should be. So you see you're arriving at these same answers. And then, there's a lot of different multiples, or not multiples, but factors of 72. But really, when you're simplifying this, you want to be looking for the biggest perfect square, okay? So sometimes it may click that 72 is 36 times 2, all right? So square root of 36, okay, we can write that and split it up again, times square root of 2. Square root of 36 is 6. That's a perfect square. So see here, I arrived at the answer so much earlier, so much quicker, okay? So that's really going to save you time when you're doing a standardized test, even, your regular test, when you're running out of time, if you can recognize the perfect square. So you'll see this a lot sometimes, and you want to think about dividing by 2. So sometimes you may see, square root of 32. Okay, that's another example. So you may be thinking, 8 times 4, and you'll go through the same iterations. But if you recognize that 32 is 16 times 2. Now, it may not always work out that way, but if you divide by 2, I'm telling you, there's a lot of times you'll see that they'll throw that at you. So square root of 16 is 4. 4 on the square root of 2 is the simplification of that root. Let's try another one really quick. So if we try square root of 98, 98 is 49 times 2. 49 is a big old perfect square, okay? 7 times 7. So bring out the 7 for the square root of 49. 7 on the square root of 2, okay, is that simplification. That reduces down to that. So again, just kind of a little time saver for you. And again, you can still work these out, the longer way, if it doesn't click. Or sometimes you just may not have a bigger perfect square. But yeah, you always want to look for the largest perfect square. And by perfect square, we mean, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, sometimes, 5 squared equals 25, and so on. So yeah, if you can recognize those, save yourself some time.